Hello everyone, welcome back to the another session in design and analysis of algorithms. Today we'll be going to learn about what is KRUSKALa algorithm, how to find out minimum cost spanning tree using KRUSKALa algorithm. So this is also one of the experiment in our lab syllabus. Now let's get started to understand about what is KRUSKALa algorithm.
So KRUSKALa algorithm is one of the algorithm in order to find out minimum cost spanning tree using greedy method. Now, so KRUSKALa algorithm, Prim's algorithm, both are different, but working principle is different. But the thing is to find out minimum cost spanning tree only. So now we'll look at KRUSKALa algorithm, how the procedure of KRUSKALa will be follows. Now, KRUSKALa algorithm is what we will be finding out minimum cost of the graph. So whichever is having minimum cost, we are not looking at the connected edge. Now let's see, 1 2 2 2 2 3, and you have the same example 20 and some 30. Now as far as your Prim's algorithm is considered, we will be taking connecting edges cost. So in KRUSKALa algorithm, will not take connecting edges, but will take minimum cost of the edge from the graph. So from this graph, what is the minimum edge? 1 to 2 is the minimum. 1 to 2 is the minimum. So we'll add this into solution. That means 1 to 2 is in my solution. Next is what? You have two things, this and this edge. Among these two, which is having minimum, that you have to consider. 1 2 3 is having minimum. So we'll take this 20. Right. Now the principle is what? Maybe you are finding the same solution. The same solution is same for Prim's and KRUSKALa for this graph, but the procedure is different. Procedure is what? You will be finding the minimum cost edge from the graph. Okay. So you will find the U and you will find V. If j is not equal to k, then we will increase I is equal to I plus 1. Now the first is what? U, the second is what? V. Now always we will calculate the minimum cost of one vertex to the other vertex. So this is what your KRUSKALa algorithm is. As far as KRUSKALa algorithm is considered, we will be going to find out the solution for this now. So which is having lowest cost, minimum cost in the entire graph? Look at all the figures, you will find out the minimum cost, which is 10. So I am taking 1 to 6 as 10. Now, so Prim's algorithm is what? We will be going for connected edge to calculate the minimum cost. But KRUSKALa is what? Finding out minimum edge cost from the graph. So after this 10, which is having minimum edge, this 12 is having minimum edge. So now take that 12. 3 2 4 is 12. So after this 12, this is step 1, step 2. Now step 3 is what? Next minimum. So this is completed, this is completed. Next minimum is what? 2 to 7. Take that 2 to 7. So after this 2 to 7, next is what? This 2 to 3. And this 2 to 3, 16. Okay. So after this 16, you can consider this 18 as it is a minimum. But if I take this 18 over here, if I consider this also, then it forms a cycle. In turn, it is not a spanning tree. So when you are choosing the minimum cost, if it leads to have a cycle, then neglect it, or then don't consider it. So I am not going to consider 18 over here. Again starts. So after that, after 18, which is having minimum cost, 22 is the minimum cost. So I am taking 5 comma 4 is minimum, which is 22. Now after this 22, again which is having minimum cost, 24, 25, 28, 24 is having minimum cost. But if you take 24, what happens? Again cycle forms. So I don't want to take this cycle. So that's what I'm not. If you take this one, it is a cycle. It is a spanning tree, right? Spanning tree should not contain any cycle. So when you are considering a cost which leads a cycle, then don't considered it. So I am not going to consider it. I am not going to consider it. Now the next least cost is what? 25. Now I am taking 25. Now as far as your spanning tree is considered, S should be belong subset of main graph, and S is equal to V comma E dash. So V is what? Number of vertex. E is what? Number of vertex minus 1. So how many vertex you have? 7 vertex you have. So number of edges should be 6. 1, 2, 3, 4, 5, 6. So total 6 edges you have, and this is what? Minimum cost spanning tree. If you see this result, you can compare the same result with the Prim's algorithm and seems to be similar. So this is what? Using KRUSKALa algorithm we find the solution. Now take one more example. This is what? One more graph. It is what? Connected graph. And the point is noted over here. Prim's algorithm will not work on not connected graphs. If I have these graph, and it is what the seems, it is what? One graph. G is equal to total 6 number of vertex. It is what? One graph, but it is not connected graph. It is not connected graph. Prim's algorithm will not work in connected graph, whereas KRUSKALa algorithm you can apply, but you will see individual spanning trees. For this is one spanning tree, for this is the other spanning tree, whereas Prim's will not work in this type of cases. Now there are 2 edges which are missed over here. Can you able to find out the minimum cost of it? Yes, you can find it out. Now we'll see the procedure how it can happen. Now what is the minimum cost among all these? 2 is the minimum cost. Now consider this edge. 4 to 5 is the minimum cost. Now what is the next minimum edge? 3, right? So here you have 3, 4, 5. Now I am considering it is 3, and I am writing here 3. Now so let us assume that the next minimum is what? 4 comma 5. If I take this thing, it forms a cycle. Okay. Now I am not going to take, but I wanted to find out I wanted to guess the minimum cost of this edge. It is 3, so I took it. It is 2, so I took it is. If it is 4, then naturally we will ignore it, right? We will not take, because we have 2 and we have 3. So as the minimum cost of this cannot be 2. If it is 2, we would have taken this only. That's what we did not taken. If it is 3, we would have taken this only. That's what we would not taken. Maybe it is 4. Because we are forming a cycle, we were neglected it. We were not considered it. So the guessing edge cost of this is what? 4. Now this is, look at this. And here you have this edge and this edge and this edge. Which you will take? We will take this. 4 and 5. 4 and 5. This is 2, this is 1. So how many nodes you have? 5 vertex you have. V is equal to 5. Now what are the number of edges? Should be vertex minus 1, total number 4. 1, 2, 3, 4. So now the same again. If it is 4, then we would not taken this edge, we would have taken this edge. If it is 5, we would have taken this edge, we would not taken this edge. Naturally it will be what? The minimum cost? 6. So this will be also helps you to find out the missing edge minimum cost. And there is one more example. So as far as this example is considered, you can take a spanning tree using KRUSKALa algorithm. You can find it out. What is the minimum cost among all? A to B is the minimum cost. That is 2. So after this, find out the other minimum cost. There are 2 edges what are having same. So A to E you can take, or B to C you can also take. Now I am taking A to E. Okay. Now after I took A to E, next is what? 4 comma 4. Again B to D you can consider, or B to C also you can consider. Now, so now what I can do is, after this 4, which can I take? If I took this one, what happens? If I took this one, what happens? It forms a cycle. So I am not going to take this into consideration. Now I am going to take this into consideration. Total, how many edges were there? How many edges were there? 1, 2, 3, 4. Total edges or total vertex are 1, 2, 3, 4, 5. So vertex is equal to 5, edges is equal to 4, v minus 1, which is 4. So the cost of this spanning tree is what? 12. So either you can take A, E, B, C, D, or else you can take A, B, E, C, D. Anything is okay, but this cost will not modify. Cost will be the 12 for this graph. So this is the way how to use your KRUSKAL algorithm. KRUSKAL algorithm is all about finding out the minimum cost of the edge in the graph. Thank you all.